Hey, welcome to the MatterHackers podcast. I'm Dave, VP of Products and Technology here at MatterHackers, and I'm excited to bring you along on this adventure diving deeper into additive and digital manufacturing. Today, we'll be sitting down with industry experts to talk about flexible filaments, 3D printing's elusive material that with a few simple adjustments and an increased knowledge can be wrangled back down to earth and easily achieve success with. We'll be getting to those specifics, as well as talking with the company that's leading the charge in producing flexible materials that are easy to use, NinjaTech, about their materials, how they came to exist, and roots in the 3D printing market. Finally, we'll cover how to succeed with flexible materials and some best applications. Let's dive in. I'm here with Sean from NinjaTech. Do you want to introduce yourself?
Yeah, thanks, Dave. Sean Gablehouse, and I am the business manager for NinjaTech 3D Filaments. So, been with the company for about 3.5 years. Managing NinjaTech since my start with the company.
Awesome. And just for those who might not be aware, who is NinjaTech?
Yeah, so NinjaTech has a pretty interesting and I think a unique background as to how we all got started. And so NinjaTech is the brand, you would say, under Fenner or Fenner Drives or Fenner Incorporated. And Fenner is a power transmission company that specializes in a number of different applications and producing materials and products for a number of different industries, primarily the power transmission. So one of the key businesses that is under Fenner is Eagle Belting. And what Eagle Belting is essentially it's a TPU conveyor belting line that we've been extruding here. So we have been extruding TPU for about 50 years. So it's been a long time. Yeah. So what has lent itself to is just an expertise and also a know-how and kind of some trade secrets that we've built up among those 50 years. And have been doing extruding TPU for that long. So NinjaTech derived from that Eagle belting line. And how it did was back in 2012, 2013, we just had this a
familiar year people in 3D printing bring up.
Exactly. And we had this very, very thoughtful and very overzealous engineer. And so he was, he's been an engineer in the Eagle belting line for some time. And this is obviously when FDM was really kind of kicking off and doing well. And I think the major materials at that point were PLAs and more of the rigid materials. So when we're talking TPU, we're extruding for our conveyor belting these flexible materials. And, he said, you know what, I think I can make this into a filament. Mm-hmm. I think I can do something with this. So lo and behold, he took it home, played with it in a I think it was like a Lulzbot printer. So he was playing around with it in his garage and got to a point, got close enough. I don't think it was like miraculously overnight he had something. So
right. Yeah. After many bashing of heads on a countertop, yeah.
Exactly. But he got enough out of that where he could bring it back in. We did some reformulations, did a little tweaks on what we were doing, and lo and behold, NinjaFlex was created. And NinjaFlex, obviously our flagship brand, was created. I think we launched in October of 2013. So that is kind of the start of our business. And
when I think NinjaTech, I think like first to market and sort of leading the market in flexible filaments. So it's so interesting to hear that the history of Fenner Drives, the parent company, have been extruding TPU and flexible belts, or at least likely they're stiffened in some way or something like that. But clever extrusion of flexible materials for 50 years. That's crazy.
Yeah, yeah, exactly. And we really, on the NinjaTech side, we really lean on that experience, and just the learning curves that we've made on the conveying belting side, and really translated that into, yeah, like you said, the first flexible filament material out on the market. And so it was actually, I shouldn't say it was an easy transition, but it was definitely it translates really well into what we're doing and what we've really built the company on.
Sure. And so are most of the flexible filaments that NinjaTech offers TPU based?
Yes, yeah. So absolutely. So obviously we started with NinjaFlex TPU, and that was, I think actually when we started the company, the name of the company was NinjaFlex, and then we transitioned to NinjaTech because obviously we're not going to have just one filament. So the next iteration and the growth of the company came from understanding our limitations with NinjaFlex into the market. Obviously, it's a little bit more. How should I say? It's a little bit more difficult to print, or it's a little more challenging to print than your other materials out in the market. And so when we look at how do we capture more of the industry and more of the market, and using and transitioning our customers still to be able to use TPU, but giving them a better experience and using the materials. Then we launched Cheetah, which was NinjaFlex being 85A, Cheetah then coming in at a 95A, which really opened up the doors as far as platforms in which we can print on, and offers print speeds that are that the market was more comfortable using, and you could print it fast. You could print it essentially on any machine available, and then also. It's just kind of a workhorse. It really gives you the flexibility, but does have some rigidity to it as well, which made it very accommodating to a lot of customers. So that then it was NinjaFlex, then Cheetah, and then we looked at Armadillo. So Armadillo TPU material, and it's a 75D material. So it's a rigid material. And when we looked at Armadillo and where does it play in the industry, it was kind of our answer, or our alternative to nylons. When we looked at nylons, and we looked at TPUs as being a good alternative to nylon as well.
Cool. Yeah, so, I mean, you can use with a material that stiff, you can use design to make it stiffer, or design to make it more flexible depending on its application, similar to nylon, I would imagine.
Yeah, exactly. I mean, we have, I think one of the case studies or the videos that we have on social media is our application engineer, Mike, who's, who 100% infill, and he tapped it. He was, he used a bandsaw on it. I mean, he used, it's a very, it's very strong. And the other thing is, the nice kind of sidebar of it is it doesn't shatter. So under extreme pressure, it doesn't shatter. It more deforms. So it adds a level of safety into the use of the material as well.
Yeah, very cool. So NinjaTech, or back then NinjaFlex's entrance into the 3D printing market was really catalyzed by like one engineer who had maybe built a printer at home and was experimenting there?
Actually, yeah, he actually had a printer. He was playing around with, I think, a lot of PLAs, and really just working with the TPU day in and day out. He, just very creative, genius mind, and just started tinkering around with using our belting that we were selling to conveying applications, and started, drew it down to a 3mm, and started playing with it in his garage printer. And so that was kind of the essence of the beginning.
That is, like I said, a very familiar story for 2012, 2013, kind of the same time frame when MatterHackers even came to market at first.
Yeah, that's great. That's awesome.
Yeah. Cool. So what is you guys are known specifically for flexible materials. And when I think of flexible materials, I think what a pain in the butt to extrude, and how are you guys succeeding with manufacturing this like very the reason it's not a very popular material like blanket in the market, I think, is because it's difficult to manage the mechanical properties, the diameter, and the tolerance in the manufacturing. How are you guys using your experience to overcome those hurdles?
Yeah, absolutely. So again, kind of leaning back onto our experience in extruding TPU. Those are the kind of some industry trade secrets, proprietary stuff that we do to the material that gives it this better printability aspect compared to our competition, that we like to think, and just gives the user a better experience with our materials. Again, that's not to say that our material is the easiest thing to print. I completely understand, and we have the support calls to back that up. But at the same time, when in the industry, obviously, the last thing you want is for your customers to get the material and just have a negative connotation kind of negative feedback of what your material provides, and so we wanted to give them the best opportunity to succeed, and I think we've done that on that side.
Yeah, I think there's always a balance there, right? To be able to try to understand that if you want to print with a nylon, you're going to have to dry it out. There's like some burden of getting started. If you want to print with flexibles, you may have to slow your speeds down and use some specific bed adhesives, and for some materials, dry that out as well. But it seems like you guys are playing that balance of material properties and shore hardnesses and flexibilities with printability. So how do you guys do that balance when you're coming to market with a product?
Yeah, that's actually a great segue, Dave, because obviously, and I mentioned this before, NinjaFlex, there's certainly limitations, right? There's certainly some printers that it just, we would not suggest being used on unless someone wanted to get down and dirty on some modifications on their printer. And so as we look down the road and what our pipeline looks like for new material development and new filament launches, that is such a key factor in how we're going to attack the market and what materials that we put out to the market. Obviously with Cheetah and Armadillo, both great materials that can be used on a number of different extrusion, whether it's Bowden or it's direct drive. And then we also have a material that's a conductive, flexible called eel. That is right around a 90A. And again, it can be used on various amounts of machines or a number of different platforms. And then our most recent launch is Chinchilla. So you mentioned, how do we look at this down the road? And just 2 months ago, we launched Chinchilla to the market. And this has been, for me at least, this has been a long time coming. This has been 2 years in the making. I remember standing at FormNext 2019, standing at our booth. We had samples of this material. We were going to launch it. It was a 70A material. It's a proprietary blend of these materials that we've actually converted from our that we've learned more from on our belting side, that we are like, oh my gosh, this stuff that we're using for this specific belt, this would be awesome as a filament, and the characteristics and everything. So, we're standing there 2019 and showing this product off, and it's got these unbelievable feel and touch characteristics, and the finish is just unique and everything. And lo and behold, one of our suppliers obsoleted one of the materials that we were using. So we're like, oh, wonderful. Well, that puts a little roadblock in. But what it did do is it gave us an opportunity to look at reformulation, because the original iteration of Chinchilla was not going to be the most user friendly. It was going to be NinjaFlex-esque, if you will. It was limited direct drive and kind of similar to the NinjaFlex. So when we went back to the drawing board on chinchilla, our engineer, Ryan Flattery, did a great job of identifying materials, still keeping kind of the base, like what we were wanting, the design requirements of the material, of the filament that we were putting to him. So he's able to kind of design a material combination that not gets us to a 75A, but it also gets us to a printability as well. So we've tested the chinchilla in different types of printers, Bowden and direct drive. Obviously, direct drive, you're probably going to have a little bit of better success, maybe go a little quicker. Bowden, but it does print in the Bowden, and we've seen a lot of success in the Bowden style printers as well. So, so your initial question saying like how are you looking at the market and making them more broadly accepted as far as the materials go, or how they're compatible with printers? That is one of our key facets moving forward, and how we launch product and what we look for to provide to the market. We don't want to get harder to print than NinjaFlex. We want to make, and I keep on saying that in regards to NinjaFlex. I mean, it's a great product and it's awesome, and it's, when you have the right setup and everything, it prints great. But at the same time, we want to make sure that we have, the ability to service a number of customers and far reaching.
Yeah, I just think of like looking for an O-ring or a belt material through maybe a McMaster car catalog or something like that. Yeah. And then you go down the list and you can sort of choose the hardness or the gumminess or the stiffness that you're looking for. Like, you guys are obviously experts in that field. What's preventing you guys from coming out with like 150 different products of different shore hardnesses, of choose your own adventure? Obviously, there's many technical hurdles there, but that seems like a cool portfolio to have that only you guys could have. What are the limitations balanced with the product opportunities when you have engineers at companies looking to make decisions more based on the material properties?
Yeah, well, it's funny you say that, Dave, because stay tuned for a new product launch coming out in a couple months. Oh, right. So so a little teaser here. This is an exclusive for MatterHackers podcast. Love it. Yes. So in a couple months, we are looking at that. So obviously we do have a vast experience in the TPUs, and as you look at all the way from a 75D to a 75A, there are gaps in the market, and not only so we have to kind of surgically look at, all right, what, not only the gaps, but also, are we adding value? Is the material, are we just, kind of duplicating something that's already out in the market? Or are we, if we find something that fills a certain gap, would it just be essentially, it's a little better, but, it would be more of a cannibalization of our existing lines. But that being said, we certainly understand that, the NinjaTek brand is known for quality, consistency. And so we certainly want to make sure that we have offerings available that kind of, that touch the gamut, like you mentioned. So sure. Stay tuned. Awesome. We have that coming in a couple of months, and yes.
I'm glad I asked the question.
Yeah, exactly. You got it out of me. No, but that's awesome. And I'm happy to say that it's coming along. We've done some initial testing. Cool. It extrudes well. It prints well. So all the signs are leading to nothing really slowing that down.
So with, we could take Chinchilla as an example, but really any of the NinjaTek products, like, who's your target market? Like, what customers are you chasing after? And then does that lead you any case studies that you're really proud of or you think are cool and would be cool to share?
Yeah, absolutely. Well, thank you. So when we look at kind of the beginning of the whole NinjaTech creation and how it started. We recognize that one of the benefits of being under Fenner is number one, we have buying power. So we do have, and we have access to premium resins at reasonable prices in which that are engineering grade resins. So because we're kind of coordinating with our industrial belting side of things, we're utilizing similar resins, or we're working. We are understanding certain properties, and so we look at the materials, and all of our materials come from engineering grade resins, industrial resins. So when we launched NinjaFlex and we launched Cheetah and Armadillo, we certainly thought or targeted, hey, these industrial uses, and whether it's jigs, fixtures, or for NinjaFlex, shoot, we've seen we've seen applications that blow my mind today. But so obviously we say, what, we come from industrial background. We have accounts that are industrial already on the Fenner side. 3D printing is definitely taking its hold and being more and more adopted into industrial production and manufacturing. So we thought, well, with our materials, we would be a nice fit and a nice add-on for those kind of accounts. And that certainly has done well for us. That being said, we've also seen that our material is fun to use, and it's a fun material to play with. So we really understand that our customers are not only the manufacturing company, but hobbyists and prosumers and customers like that, and they love our material, and they love the uniqueness of the material and the printability and all the characteristics that go along with it. So we have this industrial side, but we also have this very heavily weighted hobbyist side that the tinkerer and anyone who's just wants to try out flexibles is using our materials. So and we certainly understand that, hey, that hobbyist that may be using this for a home project or just to play around with may also be going from Monday to Friday into an engineering job. So they're taking, so we certainly, we really value those customers because they're kind of creating the ideas that then get adopted later into more of a mainstream manufacturing approach. So to answer your question, I mean, our products run, the gamut, obviously. And then when we launched when we launched Chinchilla, the design requirements were kind of unique. We were getting a ton of intrigue from practicing hospitals and teaching hospitals, as well as for organ printing. So we were getting a lot of. Yeah, exactly. So, and we have a case study for NinjaFlex from, I believe it's the University of Louisville, that when we launched NinjaFlex, it was, they did a case study around 3D printing a heart. And one of the things that we found was we had a couple customers that were asking, like, geez, do you have anything that's even more lifelike? So, as we were looking at Chinchilla and what that product would look like, we were like, man, can we make it even like, this is going to probably sound really weird, but fleshy? I don't even know if that's an adjective, but so as we looked at Chinchilla, we're like, is it something that can be a little bit more mimicking of an actual organ, of a human organ? But at the same time, understanding that it's soft touch, it's, it doesn't have perhaps that more rubbery feel that TPUs typically do. We certainly understood that for fashion, for one of the use cases is like prosthetic socket liners. That it can go right up against the skin, and wearables, cosplay, and so insoles. So those kind of applications, we thought Chinchilla would be great, and that's why when we launched Chinchilla, we went out and paid for a third-party skin-safe testing to be done. So we have, I think it'll be put on our website shortly, but prior to launch, we went out and got a third-party skin-safe test on our material, on the filament itself, and it came back skin-safe. So we wanted to make sure that if we're going to be selling into the prosthetics market, or if there's going to be any kind of skin contact, we wanted to ensure our customers that, hey, you're going to get something that has gone through testing, third-party testing, to verify that it is safe.
Yeah, that's great. I think that's, above and beyond certainly what many people would expect from a 3D printing filament, but great to know for medical applications and things like that. And it's really cool to hear that you have target markets, but you're understanding that even your target markets and, someone even maybe messing around in their garage with one spool of NinjaFlex or something are catalyzing these ideas that end up in a bigger industry and show the capabilities and the true power of what a flexible material can be used for in 3D printing. So that's really cool to hear.
Yeah. Well, thank you. Yeah, I mean, and it's really a credit to the industry, because the minds in the industry, and this is, look, my background, I come from flooring. So when I got into 3D printing, it was eye-opening to me. Like I honestly didn't have a whole heck of a lot of knowledge about 3D printing. So I mean, I was selling flooring, and so this is a completely new industry to me, and when I got into it and just seeing applications and seeing how our customers in the industry was using our materials was fascinating. And just the takeaway from going to my first trade show, which was Rapid in, I guess it was 2018. And then setting up a booth the next year and seeing people coming by and saying like, NinjaTech, I love your products. And I'm like, oh my gosh, this is amazing. Like, this is, we say that, a lot of people have a good perception of NinjaTech, but it was nothing that I had seen before. So it was really exciting.
That's cool. What in 3D printing could be your products, could be something else? Are you excited about the growth or the coming growth and biggest opportunities of the future?
Yeah, just the overall adoption of 3D printing. And I think the biggest excitement for me is when I look at the industry, and really one of the major barriers for even going even further is the mass customization, or excuse me, the mass production, but then also the materials. And I see, more and more in the industry, they're finding ways in which to either produce quicker or produce more of the maybe of that same little trinket or whatever it may be. But also the materials are getting to points in which, where at one time, 3D printing's prototyping. And now it's, oh no, these are end use parts. You see aerospace, that's taking on, end use parts and planes. And the fact that the growth and the development of materials has been astounding. I mean, even in, my 3 years of doing this, just the what's available today from when, where I was 3 years ago is just terrific. And I'm, gratefully, part of that materials side of the business, but, that's what kind of gets me motivated, keeps us motivated to pushes us to develop more products and develop more materials that are kind of groundbreaking and really taken to the industry. Material development is just amazing.
Yeah, if you look at materials where they were 10 years ago, pretty much people were printing with ABS, and that's actually a fairly complicated material to use at this point. PLA came out, the flexibles came out, nylons became more prevalent. If you sort of extrapolate what the next 10 years look like, adoption and material progression and mechanical properties and ease of use, I think it's an exciting future, as you're saying. So
absolutely.
All right, Sean.
I'm sorry. Go ahead.
Go for it.
Oh, and just I guess the one last thing is the I feel like 3D printing is kind of on the forefront of sustainability as well, and that's a really cool place to be. We want to certainly be part of that as well. So we work towards that, and hopefully down the road there's going to be some offerings on our side as well. So it's an industry unlike any I've been part of, and it's just a really fun, exciting, creative, innovative industry. So I'm grateful to be part of it.
Yeah, that's so cool. Well, we appreciate everything that NinjaTech has provided, Fenner has invested in for sure. And it's so cool to hear the evolution of the story of NinjaTech, known for their flexible materials, how it's evolved, how it's grown over the years, optimized to printability, but keeping the market open for mechanical properties. And we're excited for the growth to come. Thanks for your time, Sean. Really appreciate it.
Yeah, thank you, Dave, and thank you to MatterHackers for having us on and being a terrific partner.
No problem. Yeah, we love to participate in it and keep up on the bleeding edge of the market.
Yeah, absolutely. Well, thank you, Dave.
And now let's take a look at some of the best applications for flexible filaments and how to succeed with them. For that, I've brought in Taylor Landry. Let's start with the basics of flexible materials. What are some applications? Why would someone choose to print with flexible materials, Taylor?
I think anytime that you need something that has grip or some give, compliance, things like gaskets, cell phone cases, anything that needs to absorb shock, are great opportunities for flexible filaments. Some really cool things that people are probably familiar with if they've been 3D printing for any amount of time would be like the prosthetic hands. A lot of those parts, specifically on kids with like missing fingers, the palm parts are printed with TPE. I guess they could be TPU, but having the safe for skin contact thing is important for that. But things like cell phone cases and foot pads for your 3D printer, maybe anything that you want to dampen vibration can work with. And it's super durable too. It's very hard to break or even tear apart most flexible filaments. So that's a desirable trait for a lot of things.
They really are crazy tough when it comes to at least printing something out and trying to break it with your hands. Those some of those flexible materials are literally impossible to break.
Yes.
Manually. When it comes to some of you talked about skin safe and some adaptive medical things, those maybe why would someone be 3D printing them instead of injection molding them? Is there a reason application that 3D printing fits that?
Well, I think just the same reasons that you would 3D print anything over injection molding would be, number one, if it's a custom or low production run item, injection molding is great if you're making 10,000 of something, but if you only need to make 2, it's not really viable. So
especially when it comes to sizing.
Yeah, and that's the thing that's really cool with like prosthetics for kids is typically, at least prior to 3D printing, that didn't really happen much because they're so expensive and kids grow so quickly that you don't want to spend $5,000 on a prosthetic hand and then your kid outgrows it in 6 months and you need another one. So 3D printing allows you to make a new one anytime they need it and for very, very cheap and quick. So that would be a reason to do it. But it also allows you to iterate on a design. So if you're trying to make a custom inner phone case to absorb vibration, you could print 10 different iterations in a day instead of designing it, sending it out, and hoping it comes back correct and going through that whole process. So.
And have the flexibility to use different durometers, different materials to accommodate for whatever dampening or compliance that you need.
Right.
So we're sitting here, it's 2021, and I think there are very active people out there that are 3D printing regularly that think printing with flexibles is impossible or nearly impossible. So I want to talk to you a little bit more on how to succeed with flexible materials. What are some of the watch outs and basic settings where someone can take this guidance and succeed with the material?
Yeah, we've come a long way. When flexibles first came out, it was very difficult to print with them, mainly because of the hardware limitations, specifically around extruders. And the main issue with flexibles is because they're flexible, they don't necessarily go where you want them to when it comes to extruders.
Yep.
It's like pushing a piece of cooked spaghetti. You can't push it in a straight line. It's just going to fold and follow the path of least resistance. But most extruders, or I should say most decent or good extruders now, are very well constrained, so they prevent that from happening. Bontex and E3D and Dyes Design, to name a couple off the top of my head, they all have very constrained filament paths that allow you to print flexibles without having extruder binding issues. I mean, the main things to consider or to remember with flexibles is you generally have to print a bit slower than you do with rigid filaments.
Mm-hmm.
It's much more important for your first layer height to be accurate or be correct, because if you're a little too close, you can get away with it with PLA, but with flexible filament, being too close builds up pressure in the hot end, and that back pressure can cause issues with binding or jamming at the extruder. But if you go slow and you have your first layer height right, chances are you have a printer that is constrained enough to print with it, and that includes Bowden Setups.
Bowden Setups, not impossible to print flexibles with?
Absolutely not. So I would say that it's certainly easier with a direct drive than Bowden, but you can absolutely print flexibles on Bowden on both 1.75 and 3mm filaments. 3mm filaments are going to be easier to print Bowden for flexible because 3mm is a bit more stiff because it's got a thicker cross-sectional area that it makes it a little bit easier. But yeah, there's certainly a misconception out there that flexibles are not possible on Bowden, but that's just not the case, provided you have the right extruder setup and your settings are correct. Most retractions are not really effective or useful with the vast majority of flexible filaments and setups. So stringing is an issue, but it's an issue with direct drive and Bowden. So there's not really much you can do about that.
Pent up potential energy and the squishiness of the material is usually the ailment for stringing with flexibles.
It just acts like a big spring, so you don't really get much responsiveness on that. But yeah, if you go slow, you get your first layer right, generally it's pretty smooth sailing.
I think my biggest learning is when you think of, you said path of least resistance. We think of path of least resistance with a rigid material as through the gears of the extruder, that if it's a Bowden setup, through the tubing into the hot end and getting melted. And flexibles so often find little squirty ways and paths to just be dumped onto, into the air out the side of the extruder. So I think if you are having that failure mode, getting an updated or a new extruder is often the solution, just because there is such a constrained filament path that there are no little squirty exits or other paths of least resistance that are not through to the hot end.
Absolutely. And if we have some stuff on our site that show visually what happens when you don't have a constrained path, that's a good starting point if you're not sure what we're talking about or want to know a little bit more and make sure that you can print flexibles. But once you see it, it makes perfect sense, and it's not a difficult problem to overcome. And most printers now have certainly more constrained than they used to be extruders, and there are tons of options that are quote unquote fully constrained or as constrained as they could possibly be that should allow you to print flexibles on any setup.
And if someone who's having issues with printing flexible filaments, what's your number one answer? What's the first go-to shot uninformed in the dark of what to do to succeed?
Just go really slow to start.
Slow it down.
Slow it down and give yourself probably the other thing that may seem a little counterintuitive to to people who have had issues with like bed adhesion and stuff with other filaments. It sticks. Flexible filaments are pretty easy to stay stuck. In fact, they can actually be incredibly difficult to remove from certain surfaces.
Yep.
So start off higher, like get your nozzle farther away from the bed, and that does two things. Number one, it'll make your life easier for removing it from the bed, depending on the surface you're using. But two, you just make sure that you don't have excess pressure in the hot end, which can cause issues quickly. So going slow, once you get the flow started, that's the other little, call it a pro tip, is you don't want it to stop or change suddenly. So on a typical print, you may have speeds that are quite different for like your inner perimeter and your outer perimeter.
Yep.
But you don't want to do that with flexibles. You want to keep all your speeds basically the same so that you're not getting sudden changes in the extrusion, because that can cause issues as well. You basically just want to keep it steady and constant throughout. And it's pretty smooth sailing. And generally what I would recommend if you're trying to figure out what the limit is there is, start slow, and let's say it's 15 millimeters a second for your speeds, and just slowly ramp that up during a test print. And you'll get to the spot where you realize you can't print faster than that. Mm-hmm. So it's generally around 30 to 40 millimeters a second for many of the flexibles. It's going to depend. The stiffer it is, the faster you'll be able to go. But it doesn't take that long to figure out where the limit is and where you have to be. So start slow, keep it steady, and it's pretty straightforward from there.
One of my other final points would be, I recall printing my first flexible material. I think it was a wheel or a gyroscope of some sort, and had like this matte finish, and I was quite proud of it. But you looked at it and said, "Bro, your filament's wet. Dry it out."
Yeah, that's the one thing with almost all flexibles, is that they're pretty hygroscopic. I would say they're closer to nylon than they are PLA in terms of moisture absorption. So you absolutely need to dry them, unless it's one of the very few that doesn't. Yeah, that is not hygroscopic. But that's one thing. I would say that because of the way that people use flexibles often, like phone cases or little feet for your printer on your desk or something, it may not matter that much that it has some moisture in it, but you'll certainly get a different surface finish and get some different mechanical properties if you have wet filament. So
yeah, everything's a bit tougher when it's not spitting water while it's evaporating it. And once you do clear out the water, you dry it out for some period of time. Many of those materials are so glossy and have a pristine finish. Really can change the perception of that part.
Yeah, and they actually can print really smoothly. Like, it can be very satisfying to watch a good dried flexible filament print. So
yep. Cool. Well, thanks for your time, Taylor. All of this information, specifically the How to Succeed stuff, is in an article form and a video form on MatterHackers.com, so you can look at guidance of how to specifically succeed with maybe MatterHackers Pro Series Flex or the NinjaTech materials or all the other flexibles out there. You can find more information on MatterHackers.com. Thank you for listening. We'll keep making these podcasts. We are really having a good time and continue to learn a lot. So keep up to date with wherever you get your podcasts. For more information, you can always go to MatterHackers.com. Information on how to succeed with printing flexible materials. More information on Ninjatech and their line of materials. And generally all the info you need to succeed at 3D printing in general. We'll see you on the next one.